Hi, everyone. This is lesson 65 of our seventh grade Elevate lessons, and we are working on classifying two-dimensional figures. We are taking a break from area just for today. However, the rest of the lessons that are coming up are around area. So it tells us that two-dimensional figures can be classified based on their properties. The concept map here shows relationships among different types of quadrilaterals. We know that quadrilaterals are four-sided shapes. It tells us that a trapezoid is the only quadrilateral with exactly one pair of parallel sides. So I've gone ahead and highlighted the parallel sides for our trapezoid. They only have one pair, meaning together. So this and this are our one pair. It's our pair. A parallelogram, on the other hand, is a quadrilateral with two pairs of parallel sides. So we see that our lengths are parallel, and then the second set of parallel sides are our widths. It also tells us that rectangles, rhombuses, and squares are parallelograms. Okay, they're parallelograms because they have at least one pair of two pairs of parallel sides. Sorry. So I've gone ahead and highlighted them in the same way that I've highlighted parallelograms. And then lastly, a square is an example of a rectangle and a rhombus. So today's lesson is a little bit wonky only because there is no formal practice that is going to necessarily prepare students for their partner practice time. However, we are still going to do a model around question A and then a turn and talk after. So this question says, which of these figures can be classified in this group? At least one pair of perpendicular sides. This activity is going to be helpful because the two activities that students are going to do during their partner practice time is going to require them to do some grouping and some classification. So you want to talk through your process on how you're classifying so that they can make that work replicable, sorry guys, during their partner practice time. Okay, so it says define perpendicular sides meet at 90-degree angles. Go ahead and ask the kids, do you see any 90-degree angles? Students should be able to identify whenever they see these squares in the corners of shapes that those are right angles, which are also 90 degrees. And so students should say, okay, figure A and figure C have 90-degree angles. Nice job. So we reviewed the figures and we said figure A is a square. All of its adjacent sides are perpendicular. Figure C is a right triangle. Its vertical side and bottom side are perpendicular. So those two figures belong in the group. The other two figures, B and D, have no right angles. They do not belong in the group. Great. So now let's talk about this question right here. This turn and talk is going to be very important because it shows up again in the lesson. So please do not skip it. It says, Timothy says that all equilateral triangles are also acute triangles. So before we even get to the rest of the question, let's define the vocabulary that we see. Equilateral, triangle with three equal sides and angles. I also know that equilateral, if a triangle is equilateral and triangles equal 180 degrees, then each of the angles must be 60 because 60 times 3 gives me 180, okay? Acute triangles are triangles with all angles less than 90 degrees. Interesting. So that means that if in an acute angle all the angles are less than 90 degrees, and I just said that equilateral triangles only have angles that are 60 degrees, 60 is less than 90. So I agree with Timothy. Is his statement true? Yes. All angles are 60 degrees, which are acute angles. Okay, so now we're going to launch students into their partner practice time, 15 minutes, to kind of fend for themselves with this classification. They are going to use these figures A through F to help them answer questions 1 through 4. So they're going to find the figures with at least one pair of parallel sides. So reminding students what parallel sides are, I've highlighted them in yellow just for you so you can quickly check students' work. So parallel sides, they never cross. And so they're going to list the figures that belong to that group. And then group 2, at least one pair of perpendicular sides. Group 3, no sides are the same length. So they have to look at those numbers to identify the sides. And then group B, only 2 sides have the same length. And then for this second part, they are going to use not figures, but groups 1, 2, and 3 to help them classify whether a shape is a parallelogram, a square, an equilateral triangle, or a rectangle. So for example, which of these are classified as parallelograms? Does a parallelogram have 2 pairs of parallel sides? Yes, it does. It's in the name, parallelogram. Does a parallelogram have all sides the same length? No. Because a parallelogram from up here could also be a rectangle, right? In our concept map, it says parallelograms are also rectangles, and our rectangles don't all have the same side lengths, so no. And then, where was I? Do parallelograms all have right angles? No, because they can also be a rhombus, right? The shape that looks like this. No 90-degree angles, no right angles. Okay, so students are going to have to do the same thing to figure out, is it a square, is it an equilateral triangle, is it a rectangle? There's no exit ticket for the day. For their sprint, they are going to be working on multiplying and dividing fractions the same way they did yesterday. You may choose the inverse of whatever operation you chose yesterday for students to work on.